M.S. Ramaiah University of Applied Sciences.
Hi students, let us have a discussion on load characteristics of single-phase induction motor. The objectives of this laboratory experiment are to conduct load test on single-phase induction motor and to obtain its performance characteristics. Introduction. Induction machines can be operated as either motors or generator. However, they are primarily used as induction motors. Induction machines are by far the most common type of motor used in industrial, commercial or residential settings. The AC induction motor is well suited to applications requiring constant speed operation. In general, the induction motor is cheaper and easier to maintain compared to other alternatives. Principle of single-phase induction motor. The induction motor is made up of the stator or stationary windings and the rotor. As a voltage and a current is applied to the stator winding terminals, a magnetic field is developed in the windings. The magnetic field generated in the stator induces an EMF in the rotor bars. The magnetic field revolving in the stator will then produce the torque which will pull on the field in the rotor and establish rotor rotation. Model graphs. The performance characteristics of single-phase induction motor is as shown in figure. To verify this experiment, we need induction motor setup, 1 voltmeter, 1 ammeter and 1 wattmeter with suitable ranges, single-phase variac, mechanical load arrangement, digital tachometer and connecting wires. This is the experimental setup of load test on single-phase induction motor. While conducting this experiment, we should take some precautions which are listed. Variac should be kept in the minimum position. Induction motor should be started and stopped under no load condition. Discussion. After conduction of this experiment, calculate the various parameters of induction motor, plot its performance characteristics and comment on it. Applications. It is used in centrifugal pump, machine tools, fans, reciprocating pumps, etc.
Hi students, let us have a discussion on load test on single phase induction motor. The main objective of this experiment is to conduct load test on single phase induction motor and plot its performance characteristics. To conduct this experiment, mainly we require single phase variac. This is a single phase variac. It can also be used as a direct online starter, and mainly it consists of the two terminals. They are named as input terminals and output terminals, and input terminals are connected to the supply and output have to connect to the load, and this is the knob position to apply the required amount of the voltage. And a single phase induction motor panel. This is the panel of single phase induction motor. So it mainly consists of phase and neutral. These two terminals are used as the supply terminals. Next, this is the DPST switch and this is the indicator, and these two are the fuses. And here it consists of the input terminals and output terminals. So these terminals are used to connect the starter externally, and this is the phase and neutral of the motor terminals. So in this case the motor is connected externally by using these two terminals. Ammeter. This is the 0 to 20 amperes moving iron ammeter. It is used to measure the current, and these are the two terminals to connect the ammeter. Voltmeter. This is the 0 to 600 volts moving iron voltmeter. It is used to measure the voltage. It consists of the two terminals. So we will use these two terminals to connect the voltmeter. Wattmeter. This is the 0 to 6000 watts wattmeter. It is used to measure the power. The same wattmeter can be used as 0 to 1500 watts or 0 to 3000 watts. So based on the multiplication factor. And the wattmeter it mainly consists of the 4 terminals. They are named as M, L, C, V. These two are the voltage terminals, and M is the main, it is connected to the supply, and L is the line, it is connected to the load, and this is a common terminal. And to connect the voltage, there are the two terminals. You can use 300 volts terminal or 600 volts terminal, but if you are using 300 or 600, you should be very careful about the multiplication factor, and the multiplication factor it is based on the 1 to 2 and 1 to 1 arrangement. So if there is a, here you can see the two plates, so if there is a connection from 1 to 2 and 1 to 2, then this wattmeter is used as a 10 amperes. So you have to look at the nameplate details of the wattmeter. So if there is a connection from 1 to 2 and 1 to 2, this wattmeter is used as a 10 amperes. And suppose if you are using 300 volts terminal, then the multiplication factor is, so for a 300 volts terminal 10 ampere wattmeter, the multiplication factor should be 2. Suppose if you are using 600 volts terminal, then the multiplication factor is 600 volts for 10 amperes, the multiplication factor should be 4. Connecting wires, these are the connecting wires to make the connections as per the circuit diagram. Tachometer, this is the digital tachometer. It is used to measure the speed in terms of RPM. And mechanical load arrangement, this is a 2 HP single phase induction motor with the mechanical load arrangement. Here the output is the mechanical load, so that we will apply the load in terms of the kgs with the help of these two spring balances, and these are the two variable knob positions to apply the load. Now let us start the connections as per the circuit diagram. So first take the connecting wires. Now connect the connecting wires to the supply terminals. So this is the input terminals. Now connect these input terminals to the P and N terminals of the induction motor panel, that is phase to phase and neutral to neutral. So just to follow the color notation, so red to red and black to black. So these are the supply terminals. Now connect the voltmeter across the output terminals of the single phase variac. That is, one terminal is connected to the phase, other terminal is connected to the neutral. Now let us take the ammeter. Now take one connecting wire from the single phase variac of the output phase terminal. Now connect this terminal to the ammeter. Ammeter other end is connected to the wattmeter of terminal M. So this is the terminal M. Now short M and C terminals of the wattmeter, that is M is the main, where C is the common. Now these two terminals are shorted as per the circuit diagram. Now connect wattmeter L to the motor P. So this wattmeter L to motor P, and then motor neutral terminal to the output of the variac neutral terminal, that is N to N. So just to follow the color notation, neutral to neutral. Now the wattmeter V, that is here you can use 300 volts or 600 volts. Now I am using the 300 volts terminal, and from this terminal to motor terminal neutral. So this terminal is connected to the neutral of the motor. So these connections are finished. Now keep the meters in horizontal position. This ammeter and wattmeter, kept it in horizontal position. Now let us start the experiment, and before starting this experiment, make sure that this variable knob should be in the minimum terminal position, that is 0 position, and the load should be in the 0 position. Now switch on the supply. Now apply the rated voltage with the help of the single phase variac, that is 230 volts. Just by varying the knob you have to apply 230 volts. Now note down the readings of voltmeter. Now it is showing 230 volts, and ammeter it is showing 4.2 amperes, and wattmeter it is showing 200 watts. Now note down the spring balance reading, that is S1 and S2, and here both are showing 0. Why? Because here the motor is under no load position. Now measure the speed with the help of the digital tachometer. Now it is showing 1498 RPM. Now we have taken the readings under no load condition. Now apply the load with the help of the variable knob positions simultaneously. So apply the load. Initially the ammeter is showing 4.2 amperes. Now take the reading at 6 amperes. Now the load is applied. Now note down the readings. Here the voltmeter is constant. So under load condition also it is showing 230 volts. The ammeter it is showing 6 amperes. Now wattmeter it is 560 watts. Now note down the readings of S1 and S2. Now it is oscillating between 1 and 3. So take the average of 1 and 3, that is 2. So S1 is 2 and S2 is oscillating between 5 and 7. You take the average, that is 6. So S1 is 2 kgs and S2 is 6 kgs, and measure the speed with the help of the digital tachometer under load condition. So now the speed is 1474 RPM. Similarly, apply the load under different conditions and note down the corresponding readings of voltmeter, ammeter, wattmeter and spring balance readings, that is S1 and S2, and also measure the speed with the help of the digital tachometer. So after note down the readings, so remove the load and bring back the variable knob to the 0 position. And switch off the supply of the motor. With this, experiment is finished and plot its performance characteristics based on the obtained readings.
At MSR UAS, we spark your imagination unlike any other.